Okay, today we're going to talk about the acceleration of an object traveling in a circle, which is known as centripetal acceleration. Again, that word centripetal just means toward the center. And so we have an acceleration that is directed toward the center. We know an object is accelerating when it travels in a circle because its velocity is continuously changing direction. So the centripetal acceleration is the rate of change of the velocity's direction. It's basically how quickly the direction of the object's motion changes. We have two formulas for centripetal acceleration. One of them is v squared upon r. The other one is 4 pi squared r upon t squared. In these equations, v is velocity. There's the circular speed or the tangential speed. R is the circular or the radius of the circular motion, and t is the period or the time for one cycle. And remember again that t and frequency are reciprocals of each other. Period is measured as the time for one circle, and frequency is the number of circles per 1 second. Centripetal acceleration is always directed towards the center of the circle. That means it is along the radius. And if it's along the radius, that means that it must always be perpendicular to the velocity. So the velocity and the acceleration are always perpendicular in this circular motion. So most questions are just basically plugging in numbers into that formula, coming up with some acceleration or the radius or the period. So I'm just going to do a quick example about what happens when we double something. So the centripetal acceleration of an object is 12 meters per second squared. If the speed is tripled and the radius is doubled, then what is the new acceleration? So this is known as a proportionality problems because we're using the proportionalities that are in the formula to then try to solve this, this question. So what I know is that this acceleration, AC, must have came from one of these two formulas. And because they're talking about speed and radius, then I'm going to assume that it came from this formula up here. So I'm going to use this as my base formula, v squared upon r. I know that originally in the values, whatever values there were, I knew that the original values gave us a value of 12 meters per second squared. So this v squared upon r is 12 meters per second squared. And so that we're going to keep that in mind. So what I'm going to do is I'm going to then apply these changes to get the new acceleration. We might call that a prime or something. It says that the speed is tripled. So what I'm going to do is I'm going to triple the speed, but whatever the speed is, we have to square it. So I've tripled that speed. I've changed that, multiplied that by a 3, and that's v squared. And so we then also have to divide by the radius, and the radius here in this case is doubled. So we have to go twice r. And so again, I'm changing that into 2 times the radius that it was before. So to look at the new acceleration in terms of the old acceleration, what I'm going to do is just factor out these changes. Basically, I'm just going to write them in the front. So when I have this product squared, so when I've got 3v squared, then what I need to do is, of course, square both of those terms in there. And so I'm going to end up with a 9 in front, and then, of course, that v squared that is there. The 2 on the bottom is just that, a 2 on the bottom. And then we also have the radius as given in the original question. So remember what I said before, that this v squared is equal to 12 meters per second squared. So this v squared upon r, is equal to 12 meters per second squared. So this new acceleration must be 9/2 of the original acceleration. And so to calculate then the new acceleration, then all I have to do is go 9/2 of 12 meters per second squared. And so, of course, then that will be 54 meters per second squared is that acceleration. There's other approaches to these problems, but that's just kind of the maybe the cleanest way to kind of think about this. The other way to think about it is just what is the proportions in the question, but this is a simple process to calculating these proportion problems.